This video lesson is going to show you how to work out the following example. How many moles of nitrogen are needed if you have 4 moles of hydrogen gas? Now, I actually gave my students the balanced chemical equation for this particular problem, but there are a few things I want to point out before we get started with solving the problem. Whenever you see nitrogen as just an element, not nitrogen paired up with another element as a compound, but nitrogen by itself, you have to put a subscript of 2 because nitrogen is one of those Brinkelhoff elements. Brinkelhoff is an acronym used to describe the elements that need a subscript 2 because they are something called diatomic molecules. These elements cannot exist alone. So anytime you have nitrogen, make sure to put a subscript 2. Same thing with hydrogen. We see hydrogen gas involved with the problem, but you'll notice in the equation I have it represented as H2, not just H. Hydrogen is also a diatomic molecule. It's the H in Brinkelhoff. Now, it's important to have the proper formulas for each of the substances because otherwise, if I didn't give you a balanced equation and you had the wrong formulas, you would balance the equation with the wrong coefficients, leading you to the wrong answer. So that's the importance of that. Now I'm going to go ahead and solve the problem using a method we call GWR. GWR stands for given, want, or relationships. Sometimes you'll see relationships written as ratios, but they mean the same thing. A given is basically the only number given to you in the problem. In this problem, I have 4.00 moles of hydrogen gas, so I'm going to go ahead and write that in as the given. I like to use the formulas instead of the words when you do the GWR because it saves space, one, and because in case you need to calculate any molar masses, you have the formula ready to go. The want is the question. How many moles of nitrogen? It's really important when you do stoichiometry problems that you don't only recognize the unit, but you also recognize the substance. Throughout the entire problem, you're going to notice that I'm extremely thorough with writing the unit and the substances each and every time. The more you write them, the better you will be at determining the relationships and solving the problems without errors. When it comes to the relationships, you need to look at your given and your want for some clues. The first clue is in the substances. There's an H2 involved, and there's an N2 involved. And what that means is we are going to go back to our balanced equation and take those two pieces of our balanced equation and write a mole-to-mole ratio. A mole-to-mole ratio means take the coefficients, this is a 3, this is an understood 1, and write a relationship like so. For every 1 mole of nitrogen, there are 3 moles of hydrogen. So for every 1 mole of nitrogen, there are 3 moles of hydrogen. We're just taking the coefficients and writing a relationship between the two substances. Now, as we progress with the problem, we don't see any mass involved, no grams involved, so we don't have to calculate any molar masses for this particular problem. We also do not see atoms, molecules, or formula units. This is an abbreviation for molecule. This is an abbreviation for formula units. And so we will not need Avogadro's number in this problem either. We actually have everything we need to proceed with the problem, so let's go ahead and do that. Every problem starts off with a given over 1. Please be, again, thorough with the unit and the substance because the unit and the substance will guide you to the next step of the problem. With dimensional analysis, you always have to make sure that the unit and the substance cancel out diagonally. So moles of H2 cancel out with moles of H2, and I got this information right here from the relationship. So I'm taking that piece, putting it in the denominator, and I'm going to take the other side of the ratio and put it in the numerator. So right here, I crossed out these 2 units because they match up diagonally, and so they're going to cancel each other out just the same way that numbers cancel each other out. And now I can type this into my calculator. When I type this into my calculator with dimensional analysis, this is not a cross multiplication problem. Rather, it's like multiplying fractions by each other, and when you multiply fractions by each other, you multiply across the top and divide by the bottom. I'm going to ignore the ones in my calculation because we should know that anything multiplied and divided by 1 is itself. So in the calculator, you can do 4 divided by 3. And our unit is going to be the unit that is left over in the problem, moles of N2, which is great because that's what we wanted. Whatever you end up with in this last spot should be part of your answer. And my answer, rounded to 3 significant figures because the given has 3 significant figures, is 1.33 moles of N2.